tired. Need some breath. Oh, all better now. Time to get back to exercising.
Wait, what just happened there, other than the bad acting? Well, Exercise Mariam just experienced something called angiogenesis, and it all starts with this small, seemingly insignificant protein, the HIF factor.
In normal oxygen conditions, HIF, or the hypoxia-inducible factor, doesn't even exist in our bodies. See, in normal oxygen conditions, the HIF-1 alpha that makes up HIF along with HIF-1 beta is destroyed. This happens because when oxygen is present, a protein called von Hippel-Lindau, or VHL, will bind with HIF-1 alpha and trigger a process called ubiquitinylation, in which ubiquitin will attach itself to the proteasome region of HIF-1 alpha, destroying it. So now we have this HIF factor that's been destroyed. However, in hypoxic conditions, when our body's oxygen levels are low, the HIF factor plays a very important role in helping our cells sense the low oxygen levels, which begins the process of angiogenesis. In hypoxic conditions, due to the lack of oxygen, the HIF-1 alpha is never destroyed. Therefore, it is free to go out of its birthplace, the cytoplasm. In the nucleus, HIF-1 alpha will bind together with HIF-1 beta and boom, you got yourself HIF. Now, how does this relate to angiogenesis? Well, HIF is a type of transcription factor. It attaches itself to the promoter region of DNA and either enhances or diminishes the function of genes. One of the genes it enhances is VEGF-A, or the vascular endothelial growth factor A.
Am I the only one who thinks of vegetable when you say VEGF-A? You know, vegetable, veg.
When you exercise, your cells experience a hypoxic condition and they release the VEGF-A produced by HIF. The VEGF-A will diffuse to surrounding capillaries and the endothelial cells contained within. One of these cells, called the tip cell, will be the one to receive the biggest dose of VEGF-A, as it will be covered in the VEGFR2, or the vascular endothelial growth factor receptor 2, which will cause filopodia to protrude from the tip cell and prevent other cells from developing these same protrusions. The VEGFR2 will pull the tip cell toward the VEGF-A. The other endothelial cells contained within the capillary will multiply and create more endothelial cells, which will follow the tip cell out of the capillary. These are called stalk cells. Finally, the tip cells of surrounding capillaries will meet and create a new blood vessel so oxygen can flow through. To understand this process better, you can think of it as the scene in Alice in Wonderland when Alice ate a piece of cake and grew so big. The cake would be the HIF factor that began the process of Alice growing taller. The house would be the original capillary with the endothelial cells contained within it. The sky would be the VEGF-A released by hypoxic cells. Her body would be the filopodia protrusions. Her head would be the tip cell covered in her hair, which would be the VEGFR2.
Besides all that, the HIF factor can help us find cures for diseases such as cancer. The future holds much for this tiny protein, and I can't wait to see what more we will learn about it. Thank you!